WMI, that object broker 2.1, that has the exact same vulnerability as MS-06014, but only applies to developers. So if you're targeting a development-centric organization, you can just create this object and then use that to create any other object and own the browser in 10 seconds. So that one's still not patched. Hopefully it'll get patched eventually, but it has like a 1 in 50 ratio, so it wasn't really a big deal to the people I knew that were already exploiting it when I found it. So native code hooks. First of all, why did we bother targeting IE? We all know bloggers all use Firefox. Why don't we just target them? Well, MySpace users still use IE, so we figure, if we take down MySpace first, we can work on the bloggers later on. But I'm sorry. So I just I think MySpace is the new AOL, but that's just my opinion. Sorry, no offense, but
it's fine. It's fine.
All right, so IE is really neat to hook because it's really easy to hook. All the HTTP operations that happen in the Internet Explorer browser go through basically inetmon.dll. So there's a single DLL, and if you want to basically hook every single post call or every single GET request made by Internet Explorer, it's only a single function you have to patch. So it's real quick, real easy, bam, done. It still has, 85% market share and going down, but until then, it's a really good vector for this type of attack and this type of hook. There's 3 places you can hook an IE. One allows you to do things as basically hook all post requests and GET requests. Another one allows you to basically hook all responses from the server. And another one allows, I think it's before the user types into a form, you can hook anything they type. So basically, it's really easy to hook IE in these 3 different places to capture all data someone types in the browser, hook anything they send from their browser to the internet, and hook anything the internet sends back to them. And that's actually what we decided to use as the point proof of concept for injecting JavaScript code through the browser. With IE7, it actually kills active XSSploit, so we'll have to try a little bit harder in terms of finding new bugs. Hopefully it did a good job. We'll find out pretty soon. And who's familiar with the recent Mozilla/Firefox extension backdoor that folks talked about recently? Okay, so there is a website distributing a malicious extension for Firefox that basically captures all your form data. It was called password manager or some kind of benign name. But when you install that, anything you type into the browser, then you use the documented extension API to save all that stuff off and send it off to some other guy. So credit card information, order information, all that fun stuff is being sent off. So those same APIs can be used to hook Firefox the same way we're hooking IE with native code. And probably a lot easier because you can write it in Zool or whatever they call their programming API as opposed to having to do it all with real code.
So in terms of a potential implementation for how this would look, right? I should mention up front that we don't have a demo per se. We're going to show code, but we don't have a demo because, one, we really were banking on the Flash, the ability to use the whole Flash exploit, and God damn it, they did their jobs. So kudos to them. I'm glad that they actually fixed it. On the other hand, this is more of the thought model about how this would work, right? So notably, this is suboptimal for a real worm in a sense because ideally what you want to do is, we're targeting IE purely because of market share, right? I mean, it's got the largest possible number of users on the internet, in terms of using a browser, right? And it may change, but it's not there yet. It's suboptimal for a real worm because we do hard code some limitations, right? There isn't a lot of heuristics. What it basically is code that looks for form variables and associates them with a certain type of site, which it has some notion of some kind of injection that will work, right? So ultimately, again, if you want to spread out from the individual islands, you start to have to add essentially signatures, cross-site scripting exploit signatures to the code in order to be able to inject into multiple sites. Now, one other way you could get around that is to actively have a database of people contributing things like elsewhere, which is potentially something that somebody might do. I mean, I don't think you'd see it in a large community. What you might see it is again in the spyware and in the adware community, right? They may create, I mean, as HD mentioned, a lot of the times we can target something like MySpace, which is really, really popular, or we can target a general piece of technology infrastructure that is also very popular, like Blogger or like WordPress. Each individual WordPress site or install may be slightly different, but they're all running the same infrastructure, right? So it's almost like better target. You do more island hopping because you can just get around to every single WordPress install everywhere, right? So with those limitations, we don't have any real obvious elegant solution for that yet, but I'm sure somebody will come up with one. So in this case, what we're thinking about is something like a blog and IE as the target, right? So targeting a blog in terms of the actual web content we're going to try to inject into, and targeting IE as the browser to hook into, right? Specifically, we want to look at comments and trackbacks. because comments especially are often unfiltered. And you see this especially because who here has ever seen blog comment spam before? Right? I mean, who's had to deal with blog comment spam? Right? So, I mean, it's an obvious problem, right? Filtering this stuff is hard. And a lot of it is because you have restrictions on the basis of names, canonical names. Like you can say, oh, well, only people from certain domains can post, or I do a CAPTCHA, or whatever, right? It's not very good. Trackbacks are even worse because trackbacks aren't generated by you, right? What happens generally in the trackback is that somebody else submits information which then gets posted on another site, as opposed to going to a comment site where the information you post is still there. Trackbacks essentially migrate content to and from sites automatically. So you can look at a post, like I could look at a post if for instance, BrowserFun supported trackbacks, which I don't believe it does. You could go to BrowserFun and then you could see somebody else posting about BrowserFun on some other blog on the BrowserFun blog. Right? Not as a comment, but as they just made a post, it got synchronized via RSS and the Trackback API, and it's there, right? And so, I guess we'll go into it for now. Okay. You can go into this. Or actually, do you want to handle this? Or? Go for it. All right, so the exploit lifecycle, in terms of, if that's the setup, if that's the environment, the petri dish that we want to live in, what's the lifecycle look like, right? Well, this is where I get to define my definition of viral, right? Vulnerable web content, site or software, Blogger, WordPress, or MySpace, Zanga, whatever. Preferably something that's not only popular, but has a viral growth curve. And viral growth curve is important for true kind of like, drive-by pwning, because what we're talking about is any site where the average is that it adds more than one user for every user it adds, which is kind of recursive, right? But what it basically means is if I added HD to, pleasepwnme.com, right, and he only added another person, that's not viral. Right? We're just linearly growing one by one by one, right? Ideally what happens is that every single person adds more than one person the time that they add. So then you have this curve which slowly gets exponential, right? And that's what you want. If you're a marketer, or if you're a site like MySpace that has mostly advertising revenue, or Zanga, or any other similar site that would be applicable here, that's really what you want, right? You want a viral growth curve, because it's more users bringing more users. And that's also great for us, because it means we have more eyeballs always refreshing every single time, right? We don't have to become stale with linear growth curves or with people who patch or whatever else, right? We can try to mitigate the 1 in 10 kind of issue.
So we're going to take a little bit, a quick look at some of the code we use to do the injection, in case anyone cares about the guts of it. Hooking into IE is real easy. All you have to do is basically patch the DLL at runtime, and there's lots of ways to do that. Anybody who's used Ilfax hotfix for WMF, or Alexander Sotorov, hopefully I pronounced that correctly, hotfix for one of the recent vulnerabilities. I think he also did WMF, but there's another vulnerability previously he also patched. It's the same thing. Basically, you want to hook whenever a new application is created, you want to load your DLL into the process space, find the code in question, patch that code so it does something else, and in their case, block a vulnerable function. In my case, automatically capture all post requests and modify them in transit. After you hook the actual browser, you want to actually look at the content of the post request, fingerprint that, figure out what application they're currently posting to, and if you don't recognize it, pick a generic method that will probably work for that application. Or decide that, hey, I want to be stealthy, I'm just not going to inject into this one. Eventually, we have application-specific code injection. So for something like WordPress, you have to use style tags to use JavaScript injection. Or something like Blogger, if you can find a way to inject cross-site scripting stuff there. Or to MySpace, the comment spam or email, or whatever happens, whatever you want to do there as well. The easiest way to do this, of course, is via JavaScript include. Basically do something that eventually writes a script source include and basically stick all your code onto a third-party site. The disadvantage to that, of course, is once that site goes down, your virus doesn't work. So you need to find better ways to distribute your code, and whether that means compressing the entire thing and sticking into one big JavaScript chunk and injecting that into every post. There isn't really a good way to do that. What we've seen so far is because just storing your code on a third-party server works so well, there hasn't really been a reason to change that. It takes people such a long time to take down a server hosting malware that even if you only have a 3 or 4 day gap to launch your worm, it's still enough to make enough money to retire and buy an RV or whatever you want to do with it. So we're going to look at the code for a second, and then we'll probably go into Q&A stuff. So if anyone cares, this is actually a complete rip-off of Ilfax WMF hotfix, just kind of a demonstration of how to repurpose code. So we look for wininet.dll. Is that actually readable from anywhere?
Yeah, people in the back, can you see this, or can I make the font larger? Larger? All right, let me make it larger quick. How is that? Is Is that readable in the back? Yeah? Okay, great. Okay, go ahead.
So the first thing we want to do is find every module named win9net.dll. Hang on. Getting used to the whole Mac keyboard again. Printf, boring. Page down, this is a strange place. So first we want to, find the address we're looking for. In this case, we're looking for, where's
What do you need?
the N key? It's just hard to find, sorry. So if we actually look at the memory for HTTP send request A, that function in win9net.dll, we'll notice that for the most part across every version of Service Pack and every version of Windows, it's about the same. Push EBP, move EBP, ESP, push byte, push some dwords, do some stuff. So basically the prefix for this function is about the same. There's a couple changes in XP, but not too many. But it's pretty consistent is my point. Like, if you patch it one way, it'll probably work in every other system with a couple modifications. So all we do is basically replace the very beginning of the function in memory to jump to our code instead. And that happens in this block, hook start, where, keyboard. Here we go. So we find the address, we change the permissions of it to be, page execute, read write. Then we patch it with our code that basically causes it to jump to our function instead. And here it is. So we make it a jump instruction, then we make it a relative jump to the DLL in the memory based on the offset. Kind of standard stuff for hooking, not very exciting. And finally we get to our code that actually hooks the function. So anytime you post to any web page, this little block of code gets called. And all this does is a little assembly stub that just takes the arguments that are currently passed to it and pushes those onto another function that does the filtering, which is this. So here we see, we've got different flags. If there's no data in the post, we just ignore it. If the data is longer than basically 0 bytes or more than 0, then we actually look at it. And here we do fingerprinting for, like, say, blogger.com. This is actually an old copy of the code. So it doesn't actually have the logic. It just has the notes in it. So we see the word post body anywhere. We realize, okay, this is the blogger.com post. We know how to bypass it based on these kinds of embedding. Restrict script tags, comments are stripped from all JS content, but we can probably inject JavaScript someplace. I think it's my other code that actually has the details on that. Then we have WordPress. So how do we detect WordPress? We look for WPN once variable, we look for the user ID, the variable, the post, things like that. And where's the actual post data? There you go. Content, bling, bling, shala, bling, blong. Okay, now that was actually just test content so I could find it. But so you look for the content variable followed by the post title, you realize, okay, this is WordPress, we need to inject it a different way. In this case, all we're going to do is replace every one of the posts with new var equal, script hello from XSSploitation. This is a really boring version, but this is my old code, not the stuff we're actually still working on. And that's basically it. So tiny chunk of code that does patching. All you have to do is basically anytime a new application starts, you have to load some code that finds the DLL, patches it, jumps to it, and so on. And you can do that via the app-init DLLs key in the registry. So anytime a new process starts, you automatically hook that process. So simple stuff. It's the same way most malware works, the same way most hot fixes work. But now we're using it here for automatically hooking all IE posts. So eventually when we have this cleaned up and less ghetto and less verb off of ILFAC, I'll post the code to the Metasploit website.
I'll fix that. So, I mean, one question to ask, obviously, is like, okay, you just saw the code that we hook into IE. How did you get it in there in the first place? Like, 31 days of 0-day vulnerabilities, right, to start with at Browser Fun, right? So people are already doing this, right? HH control is already being used. People are already doing this kind of thing, right? They're doing it less well than we are positing here, but I mean, I wouldn't be surprised actually if we've been beaten to the punch a long, long time ago. Right?
I mean, the easy shellcode for all these vulnerabilities is to run